Okay, welcome to lesson 4.3. This is the last lesson in this very short unit on algebraic expressions, exponent laws. And so what we're going to do is we're going to start with for the algebraic expressions, it's very similar to what we did in unit 2, but it's not, but we're really focused on the exponents. And really this becomes a culmination of the integer exponents, the fractional exponents. We're going to see all of that in this lesson. So first off, we just have to kind of look at this. I just asked this question because I just want you to look at the x's. So I'm highlighting the fact that there are 2's in this question, there's an x, and there's y's in this question. And everything else is we're really, like all the exponents are just really counting how many of those do we have. And so if we look at this, we actually have -3 here. If we bring that to the 3, we actually have -9 on the top and 6 on the bottom. And so that kind of helps us still count the number of x's. Now we would do this question with the 2's and the y's, but I just want to look at the x's first. So we can slide that x to the -9 down, or you could just use the exponent law to subtract. But you end up with a 15 x's on the bottom. So in this answer, there should be an x to the 15 in there. Okay, we'll do this as an example. So recall the big idea is we're just counting the number of times we multiply a number and summarizing it with the exponents. So we're going to simplify this, and so we see we've got the 2 there. I wanted to talk about this. This 2 does not have anything to do with this -3. This is 2 times x, or 2 times x to the -3. This -3 applies to that x, and you know that from brackets. So the 2 actually sits there by itself. So when we use the down slide there and actually slide the negative exponents up or the negative exponents down, the down slide, I'm trying to push that idea. It's just really a joke. So what these arrows are not to move everything. It's not to take the reciprocal. It's just to y to the -4 goes up, x to the -3 goes down. Then we're just counting it. I made a mistake when I did the math type, and so I put y to the 4, I think. And so if we count 2 y's and 4 y's, we have y to the 6. The common thing though that people ask is, does that 2 go down as well? But that 2 has really nothing to do with the x to the -3. The 2 stays there. If the 2 was raised to the -1, that would go down. If you have trouble thinking about that too, or understanding it, ask yourself what exponent is on 2. And if there's no exponent, we just think of it as 1. So 2 to the 1. And we just leave that as our final answer. Next one, this is actually from the warm-up. So now we've already counted the number of x's. We're going to count the number of 2's and the number of y's as well. So the first thing we have to understand is that the 3 goes to all 3. It goes to the 2, the -3, and the 2. And the 2, likewise on the bottom, that's +2, goes to both the x and the y. And so we're left with 2 to the 3, which is 8, x to the -9, y to the 6. So this is raising 2 to the exponent 3 is 8. So some people ask why isn't it 6? Don't if you're raising it to the exponent, don't you multiply? Don't get that confused. You are multiplying. It's 2 to the 1 multiplied by 3 gives 2 to the 3. That's why you multiply here. We got x to the 6 and y to the -8. Now we can do the slide. We can slide y to the 8 up and x to the -9 down. You can also do the exponent law, -9 minus 6, and get -15, and then slide that down to the bottom after. But I just find that this is easier because it avoids having to subtract negatives. If you had 6 to the -8, a common mistake there is just to make a mistake and say it's +2 or -2 or something. But it's actually +14. Okay. With the cubed root, remember that the cubed root is an exponent, and what's very probably helpful, just so that we can use what we've done and use what we're used to doing, is actually write that as an exponent. And so you ask you what exponent is that? So it's to the 1/3, and then the square root is to the 1/2. I made that a little bit bigger, and it's a little bit more cloudy just because when we did this in class, it was a little too small. So the square root is to the 1/2, and the cubed root is to the 1/3. It doesn't really become that much harder than what we did just in the question before, right here. Like you're still just bringing the exponent into everything, but you just have to ask yourself, like, what is 27 to the 1/3? What's -3 times a third? What's 12 times a third? What's 16 to the half? What's -8 times a half? What's 12 times a half? Okay, and so we end up with 3 a to the -1, b to the 4, and 4a to the -4, b to the 6. From that 27, a third of 27, like if we're going to raise 27 to the 1/3, is 3, because 3 times 3 times 3. So if you break 27 into 3 parts, you get 3. Now you can do the slide. We slide a to the 4 up and a to the -1 down. And then we kind of put the exponents together, but like here now we're subtracting them. It just becomes a little bit easier to deal with because you don't have negative exponents. So the 1a on the bottom cancels with 1a on the top, and the 4 b's on the top cancel with all but 2 b's on the bottom. And so we're left with 3a to the +3, and then over 4b to the +2. There's something similar here. If you have a decimal exponent, what's maybe best is to write it as a fraction. And so there's two ways you can actually do this, and you can try it on your own and see if you get the same answer. But you can bring the -1/2 in to both the 4 and the 6. And if you bring the -1/2 into the 4, that does hit all of these as well. So you don't bring it in to all of these. You don't bring the -1/2 into the 3 as well. Like if it hits the 6, it's already hit to the x3. And we're going to bring that exponent in after anyway. You can also bring these exponents in on top and simplify things the best you can. The only thing I'd say there is just when you get 4 to the 4, if you're not comfortable doing that, which is not that high, but if you get 4 to the 4, then you maybe just leave it as 4 to the 4, and after you bring in the -1/2, that will take care of the size of that. So bring the -1/2 in, multiply 1/2 times 4, you get 2. 1/2 times 6, you get -3. Then we can actually slide it. We don't have to bring the negative in. Like I want to get rid of the negatives right away, so this is one strategy. You don't have to do it this way. You can bring the -2 in. But if you slide it right away, it changes the exponents right away to positive. And it just changes the exponents on the top. Like remember, this is the base. We don't really care what's inside here. All we know is that it's got a negative on it, and so when we slide it, it becomes positive. Then we got x to the 9 on top and 16x to the 6 on the bottom. And the x's cancel out, and we're left with 3 of them on the top. Okay. Last one, it actually looks like an ugly question, but it's actually a little bit easier than the ones we saw before. The question is, if you have the same base, what do you do with multiplication? What do you do with division? And so as long as you can add and subtract the exponents, we're going to add the exponents on the top and subtract the exponent on the bottom. And so that's what the question becomes, and really that's all it becomes. I just caution you here, like a lot of people kind of, like maybe when you subtract, like you don't put brackets around it. And so realize that is a subtract 2 and an add 5, because that's a -5 there. We don't have to do this here, but if you break this up as x to the 2 and x to the -5, that's actually equivalent, and x to the -5 can slide up to become x to the 5. That's what's kind of happening here with the negative and a negative becoming a positive. So this is actually going to become a +5 because it is actually going up to the top. And so we're getting 3n plus 5, and then to simplify, that's our answer, x to the 3n plus 5. Okay, and so there's some practice.